So thanks for the invitation. Nice to catch up again. The last time we met was in person was a long time ago, I think. So today I'll talk about the title is Architectonics from Artificial Minds, which is sort of inspired by the name of the course, which is the Architectonics from the Mind. But in this particular lecture, is more about this double meaning of the artificial and the natural minds. So I'll talk about some bit of a theoretical framework before proceeding with some projects, and I think I will spend a bit more time on the brain part of things. So I work sort of across different spatial scale, but underlying all of these is the use of deep neural networks, which I was working on it when I was at PFL doing my PhD a number of years ago. Let me go to the next slide. Also a bit of introduction. So the kind of work that I do could be found in different contexts, maybe the standard design, architecture biennale, design awards, and more recently the World Architecture Festival, which is next week. And also in the computer science context, like ICCV, NeurIPS, CVPR, AAI, and also industry projects, which there are quite a few of which I probably won't show any or many at all for this particular lecture context. Projects that I'll probably show some that's related. For those who are, so I actually got interested in this neuroscientific side of things actually in a very indirect way, actually via the work in deep neural networks, which obviously share similarities in, at least metaphorically, but also conceptually. And so for those who are keen to check out my work in more detail, these are some of the more easy reading books. Either I've contributed chapters or I've written one of them, and all my work been featured in there. The latest one is the one at the bottom right. We have a book launch event in Cologne in I think a few weeks time. Yep. Also quite a few coming up. Interestingly enough, quite a few about tectonics. I'm not sure why there's this sudden interest in tectonics. So there will be quite a few coming up, articles coming up in next summer. And also those who are interested in more technical side of things, there have been papers that have published in CAAD, but these are more, not so much related to neuroscience or neurocognition, but more in terms of ways in which to encode or represent architectural forms in order for deep neural networks to ingest those representation in the most supposed to appropriate and relevant ways. So for instance, there are, the one on the left is on if imagine sort of an auto-completion instead of text, you have the auto-completion of volumetric programmatic volumes using graph neural networks to learn long-range dependency and short-range dependency. And also more recently, another paper on bridging BIM and AI, looking at the BIM ontology and then using graph neural networks to sort of complete the graph in that sense as well. More AI research work from ICCV on SyncGraph, 2D SyncGraph, and also AAI in metaverses. The project on the right, I'll talk a bit more later, because there is quite a bit of eye tracking and EEG use for the generation. Also quite involved in the, so for those who are familiar with the AI conferences, NeurIPS and CVPR are two of the quite important ones. Quite involved in the the AI art context. This December, for instance, there will be a NeurIPS art exhibition in Vancouver. So let's get back to the original topic. So I tried to break down the title a little bit just to clarify the structure of the presentation today. So on the one hand, we have the architectonics, and then the other one is the artificial minds. So architectonics, in this presentation, will be sort of elaborated via tectonics and artifacts. In terms of artificial minds, by the notion of reasoning and experiencing. So I'll talk about the first part, which is about tectonics. So I use the word neural quite loosely in the sense that it can be the neural in the nervous system, or the neural networks in the brain, or the artificial neural networks in deep learning. We are familiar with the topic of tectonics, maybe as early as early 19th century, right? Karl Bottker, Gottfried Semple, Edward Stickler, and obviously Kenneth Frenton, very familiar, in which he, in a very simple way, defined it as the poetics of construction. And in the case of neurotectonics, if we understood it in a deep neural network sense, is essentially, at least the way in which I define it, as the poetics of sampling, which is in fact my PhD research back in PFL, architectural sampling, which was basically about trying to find ways to represent 3D forms in very formal ways. And with the tectonics, there is this idea of the traces of their presence. So the architectural artifacts, you could understand the presence, the perception of the architectic tectonics could be via the very material construction, the joints, the materials, the structure. These are sort of the artifacts. Whereas in the case of neural artifacts is something much more computational, which I call it the traces of the neural sampling. And to understand tectonics is to begin to follow the traces of the artifacts. We know artifacts could be understood in various ways. In the world of the art and design, it could be understood as something made by a person of great historical interest. In science and statistics, is essentially an inference that results from that do not actually reflect the real world, an unintended consequence. But more importantly for us is the third one, which is a glitch, could be understood as a fault, as a trace of the underlying algorithms. And very quickly, in fact, I'm working on an article about this, but there are many traces of these AI artifacts. Two of them, for instance, the ways in which I conceptualize them is such as slippage, which is linked to the idea of concept drift. If you are familiar with data drift, then this idea of a concept drift. Artifact 2, for instance, is the notion of doubling, which is in AI speak, they call it the Janus effect, where you have this sort of a multi-headed situation of forms because of the confusion of what's considered the front and the back or the side. In architecture, it's actually quite interesting because it's way more ambiguous. And the third one is the notion of incompleteness, which is sort of this idea of a temporal inconsistency, actually. So I'll elaborate a bit, but I will touch on the second one more deeply. The first one, so concept drift is the drifting of the ways in which we concept, meaning the change of a concept. So for instance, if I consider certain things, certain emails as spam, and 2 years later, I don't consider it as a spam, but the machine insists that it's still a spam because that was the original concept. But basically, the concept of a spam has drifted. So there is this slipperiness of this text to image, this text to 3D, the ambiguity of text and its intended manifestation. So obviously, this is not a pie. It's interesting because it's this deliberate contradiction of the word and the intended conceptual articulation, which is the idea of, contradicting it. You're right, you're seeing a pipe, but it claims that it's not a pipe. So this is one way to look at it. The other one, which is the Janus effect, I wrote quite a bit on it. Recently published an article about this idea of inverse photo architecture. Architecture is the sum of its text prompt and camera views, and is the notion of where many of the 3D non 3D aware models trying to construct 3D. So for instance, if you ever try to look at, I don't know, the Villa Savoye, usually you see certain views, or any building, in fact, there are views that are being discriminated or not being sort of emphasized. So in this case, for instance, there's always this confusion of which, the head, always this notion of the Janus head, which is this mythical god. This one I'll talk about. This is the more recent, in the sense that there is this, if you look closely at this 3D form, it never converges. It never converges because there is this inconsistency in what's being generated. It's this endless spiral loop. And this is when you try to do 3D videos through 3D forms. So the first one, the notion of doubling. So for those who are familiar with architecture history, the book called by Robin Evans, The Projective Cast. And in the concluding chapter, there is this diagram, projection, and is analoged, and is trying to understand how the imagination, which is the top right corner, actually I redrew it. Sorry. How the imagination project an imagery of perception that then allow one to construct the same object in different ways. So there are different ways to go about arriving at the design object, maybe via, at least traditionally, the orthographic projections, and then back to the 3D forms. This transition is actually in two directions. More easily in some of the vectors, but not always the case. So in this recent book article that I published is to look at it in a different way in relation to current text to 3D neo-radiance field, 3D Gaussian slatting approach. So traditionally, we see it as kind of a 3D to 2D. Depends if you are drawing the object, then it's 3D to 2D. If you are creating the 2D to generate the object, then it's 2D to 3D. But there is also this idea of extracting, which is the capturing of the profile of an object, and then using that as a basis to create a three-dimensional form. So it's sort of a 2D to 2D profiles to 3D object. And here what we have is way more generative, which is inverse rendering, which is the very basis of current state of the art that sidestepped photogrammetry, because in this case, you create the 3D from the 2D images and you infer novel 2D views from what you have by training MLP, multi-layer perceptrons, to do that. So if you redraw this thing, replacing it with Villa Savoye in this case for familiarity, and we could see that there are many ways of thinking about this in the scenario of deep generative models. So, for instance, if you look at the top one, you can check the book, but I'll just talk about it very quickly. So the architect, unlike the sculptor, we have the imagination, which then project and sort of an imagery. And in the case of image text to image, where you have a problem, and then via text to image diffusion models, in this case, let's say it's pre-trained, of which then you may fine tune it with whatever, LoRa, Dream Booth, or texture inversion. And then it could then generate the the 3D from which was previously not possible. So it's sort of short circuiting some of these directionality that was originally conceived by Robin Evans in his book. For instance, in the case of photogrammetry, it's basically 3D back to 2D and then back to 3D, right? It's a reconstruction problem. Whereas in the case of this this path is diffusion models, text to 3D diffusion models, maybe Dream Fusion or there are many. Yes, so but now it's also increasingly I'm interested, and we've been working on how could we get the implicit imagination or the projection of those imagery via the brainwave signals as the sort of the most primitive, the most raw kind of input. And we started working on that in combination with other kinds of biometric sensors, eye tracking and EEG in specifically. This is just a close-up view. And the other part is this idea of reasoning and experiencing. And it's very interesting because we know LLMs, large language models, are very bad with reasoning, or even if it looks as if it's reasoning, we have no clue if it's true reasoning. And therefore, more recently, there is, for those who are familiar with the AI context, Fei Li, she's the godmother of AI. And she quite recently got funding to create a startup called World Labs, which is essentially about spatial intelligence. And this is particularly interesting, at least for architects, because what she's trying to do here is to create large world models, which allow a much more real and multi-modal way of understanding the world, where you could generate, interact, perceive, and she calls it spatial intelligence. So I think they raised like 230 million US dollar for this startup. Of course, there are many people talk about spatial AI, spatial computer, but in the case of Apple, it's more like AR, XR, VR, not so much of relevance. If we think about spatial reasoning, actually spatial reasoning is sort of a spatial temporal reasoning, because which I will show quite later in some tests. It's really about the manipulation, the mental manipulation, at least in terms of the bio-natural spatial reasoning by humans, is to manipulate via a series of transformation over a period of time. And this is particularly relevant to architecture. So this book, for instance, by Gerber, was really about about spatial abilities for the architect, trying to understand. But essentially, it is a test of not the intelligence via a linguistic focus way of thinking, like in Turing test, or the Lovelace test, which is essentially a creativity test. There have been like many versions of Lovelace tests. Same for Turing test. So the first one is really very much on the language-centric approach of intelligence. The second one very much on the output-centric test of creativity. Whereas spatial-centric test is probably about reasoning and generativity in the sense of creativity. So very quickly, this is some examples of spatial intelligence, where for the first one, for instance, is to fold it, right? You fold the dotted lines and then figure out which is the folded version. For those of you who are fast, you can actually remember the answer, and then I'll flash the answer immediately after this. And then the second part is basically rotating in 2D, right? To see if you rotate it clockwise or anti-clockwise, which is the one that will match the diagram on the left. This is completely temporal, which is basically turning the gear in order to figure out which way it is going. This is more artistic in the sense, it's more analogical because it's a different kind of reasoning. It's they call it abstract reasoning. The guess given this sort of operation, what ought to be this answer given the same operation? So very quickly, these are the answers. Yeah, so if you manage, it's quite interesting. It turns out that large language models are actually not very good with 3D spatial visualization in that sense of reasoning. So for instance, they're very bad with these ones. The box folding that we just talked about in that spatial intelligence test, but also pretty bad with abstract navigation or even drawing of diagrams, which is actually quite crucial in architecture because it is this very nice compressed way of representing architecture concepts. But we'll just look at one of them, which is the box folding, the same thing that the first of the 4 tests. So if you ever try on Claude Sonnet, for instance, 3.5, you would actually see that it is reasoning in a different way. I mean, these are the sort of process, but we'll just zoom in on one of them to illustrate the point. So the question is, when folded, what pattern is possible? So looking at this, it's supposed to know the same exact test, right? Which is the answer? And if you look closely, for instance, the LLM is really just looking at the numbers, regardless of the orientation of the dots. And based on that idea, in fact, sometimes it also counted the number of, the wrong counting of the dots. Sometimes it counted like 4, but there isn't any really. And the answer is actually A. I mean, for Claude Sonnet is actually A and C, but obviously the answer is C. And at the end, it says that the answer is A. But so what we're seeing here is that the LLM is trying to solve this with verbal reasoning strategy, not spatial reasoning, because it's unable to articulate the spatial information. However lengthy the description might be, maybe it's possible, it's just a bit clumsy. And then also it's just looking at the content of the sites. It's not about the arrangement nor the orientation. So this is quite interesting. In terms of natural spatial intelligence, this is from mid 20th century, that this psychological test with famous architects. And one of the tests was to complete given this as fast as possible and give it a name. So they did this experiment with a number of well-known architects in the States, and these are some of the outputs from them. We kind of have had that back in 2017 with SketchRNN, recurrent neural networks, but it's sort of limited by its class. So it always generates a bus or a fire engine, however, whatever that is, given the blue line, right? So we kind of have that, and but there's this other part which is also quite interesting. This is sort of a side track. Quite a fan of this Korean artist. But what's interesting with the work is to interpret this. I mean, with this kind of experiment with GPT-4, to say its ability to interpret. So unexpectedly, in this case, the one on the left is a bud with 2 new leaves. Like, okay, so presumably this is a stalk, this is the flower. And here it says a cloud on the left, top left. And so it's essentially unexpected. The AI models will not figure this. So it is, in a way, there is a kind of a creative generative interpretation that is a bit missing. But yes, again, almost many number of years ago, there have been such as the quick draw, is where you draw something, the model will tell you what you have drawn. So it's always trying to interpret what you're drawing. So if you draw something like on the right, it looks like a bike, it says, it's a bike. But it's also limited by its taxonomy or its ontological description of what's possible. So having said this, we've sort of quickly look at these different ones. I'll jump quite quickly to the other projects because I know I have limited time. So we have projects. Quite recently, we finished one with the URA, the Urban Redevelopment Authority. But I'll show another project that is also at that scale, which is something that we're working on within SUTD. We call it the design brain. And the idea is to look into the design reasoning part. Apart from leveraging different more domain-specific models, multi-model AI. So in this case, for instance, if you combine different domains, you may get interesting overlapping intelligences, right? So this is the demo that we did quite a few months ago, where this for illustration, given whatever file type, whatever description, problem statement, contextual data, you then chunk out. But the crucial part is the design reasoning, which is the ability to almost go back to the future, to then talk to the object in almost like a cybernetic sense, but conversational sense, and interact with it to find out why is it doing what it is, why does it look like this, and from there, it is what we sort of call. Once you're able to do that, you can actually have a different trajectory of the new design. So it's something that we're trying to work on right now with multimodal model AI. And this is an old project, but just show it because it's one of the earlier project that we look at 3D generative adversarial network. So train a generative adversarial network GAN on 3D models with semantics. So this was 2021. It was before the diffusion. It was the world of generative adversarial network. And it's trained in 3D and it generates in 3D. And we basically just sampling from that latent space. And the training set consists of high-rise public housing buildings. But within that, to solve the difficulty of scaling in 3D, right? It's one thing to say 2D resolution, 3D resolution, something different, is that we embed a parametric model that is able to retrieve the probability distribution of these voxels in order to generate high-res and full 3D models. And some of the data set actually literally in the early EDA, right? Exploring the data and analyzing it. We're doing sort of trying to make sure the data set is diverse enough without so that the model generalized in a more balanced sense. Because, for instance, you don't want to have point block all the time in the whole data set. You want to have a nice spread of slab block, cluster blocks, point blocks, and so on and so forth. And yeah, so this project will be actually presented next week, although it's quite old, but yeah, for the World Architecture Festival. Anyway, I'll skip quite quickly to the other ones. It has been exhibited in a few places. So this project I'll skip. I know I have 30 minutes. But we're doing something, also trying not so much to reason, but to interrogate a given set of modalities into different augmented version of their modalities. So given an image, what we do, so this is a collaboration with ZHA, Zaha Architects, since last year. It's still quite, sort of very slowly in progress. But the idea is to extract more information from image to text, and then from image to image to text, text to graph, and then which is this idea of extending the data set information. So we have so far looked at 169 projects from the practice and some early work on trying to generate directly with specific concepts that we have fine-tuned. And yeah, so this I'll skip. So this project is more on the sort of supposedly the earliest text to 3D built object. In this case, a commission by the National Arts Council, where you extract, the idea is to create a bench that could understand very specific Asian antique furniture, but also the idea of boats, because it's sited between the river and behind it is a museum. And so we fine-tune a model that allow us to then reconstruct it, not reconstruct, but generate it in 3D that has this idea. And it actually suffers from, in a good way, the Janus effect, because the front is, if you took a full elevation of it, it looks like the front of a bench. If you have taken a elevation of the back, it also looks like a front. So there's a bifurcation along its side because the model is trying to figure out if the back is the front and the front is the front, then what's the side? And it did this sort of split, which was rather surprising. This is also a recent project that we do, but Arjun just gonna jump to the neural part. So this neuroaesthetics, something I'm very interested in. So our setup is quite simple. We're still in, I mean, there are new sensors that we're procuring, but some of the earlier one that we did, essentially desktop eye tracking, EEG. So with the Tobii X3, with the InnoBio 8 EEG, and we use that to work on some of our experiment. One of the important things that we've been looking at is the ability to actually just have the FAA value, which is the fundamental alpha asymmetry, where it allows us to have a sense whether something is positive and negative. So if there's a stronger signal on the left side, it means it's presumably more pleasurable, versus if it's negative, then it's less pleasurable. So there is some way to kind of identify. But basically, this project is to create a metaverse by training four GAN models, of which there are three modalities: images, natural images, and we train a model. Artificial images, meaning the images that we see online that been always attractive. They tend to have this archetypal kind of circle primitive shape somehow. Don't know why. And then we have the spectrogram representation from the EEG. We have the gaze map pattern, the heat map from the eye tracker. And we do a conditional generative adversarial network to learn given an image. So we train the models with pairings of image and spectrogram, image and the eye tracking. And then we turn it out into a generative model in the sense that given any brain signals or any gaze map, generate me an interior. So this is how it looks like. We have 4 different AI models with three different modalities. And a quick video. So this was presented at the AAAI, the AI conference, and on metaverses. I'm not sure you can hear the video, the audio, probably not. You probably can't hear the video. But here, the idea is that we could use space as a way to remember things. And the idea is that it's a personal metaverse. So given any objects that you're seeing at that very moment, if it triggers the exact same EEG signal or gaze map pattern, we can replace it. So it becomes a highly personal metaverse, which currently is never the case, at least how the big tech been imagining metaverses, as they tend to be quite generic and rather shallow. And then we have also worked with a furniture company. So this company is called Ipsum. They are, in fact, the Finnish company that did the Crazy Rich Asian floor lamp. that looks like a palm tree. And so this was last year, and we did a prototype. Back then, were basically, so the idea is that user could just choose any furniture, it would populate the space, and then you would generate the interior. But at the same time, we also track the user attention. The slide at the bottom represent the frontal asymmetry value, positive, negative. Just to know that what someone is looking at is actually pleasurable versus not pleasurable. And then we did some outpainting work for that last year, and it was shown on at the Singapore Design Week. More recently, we looked at a combination of rule-based systems with large language models. So Birkhoff aesthetic measure is quite well known, and it's a way to measure the aesthetic value. So in this case, we actually use the ChatGPT to generate the values. Also use, obviously, diffusion model to generate images. But here we define order as symmetry and balance. So, and then complexity as the number of elements. So we use segment anything. We look at the histogram of the images, and we also look at we use ChatGPT to extract some of the idea of symmetry, the idea of vantage point, meaning it is sort of a very composed perspective that tend to create order. And we did it with and without the EEG, with and without the eye tracking, to validate whether the Birkhoff's aesthetic measure actually align with the implicit the sensor output. So for instance, on the top bottom, so the one with the highest Birkhoff value is the one on the bottom right, the green box. The one on the top left is the lowest, meaning it has it has high order, and so n equals to O divided by C, right? So more order and less complexity. In this case, we compare it with the EEG and the eye tracking maps, and we found that some of them actually make sense, meaning it corresponds with the Birkhoff measure. We also did some I can skip some projects that we did to just have another form of understanding spaces without the human, but on the furniture. And we move on also to look at buildings, facade. So this is a project that started off with the master student, and then we begin to extend it with other ones. So it started off with rule-based system, right? In the sense of how do you actually measure the former components of high-rise building, which is very different from a house, right? Because it tends to have high verticality. So the idea of the horizontal vertical ratio, the figured ground, the convex hull, and all that as the so-called facade measures. And once we have that, we can actually map the different facade into the same space of representation, with the same number of dimensions, with the same features, right? So therefore, we are able to then compare them. And if we flip that from a predictive model, so this is a work that we are still progressing, is that quickly to generate a syntactic sets of facade, but using image-to-image models to generate a more realistic looking facade, so that it makes sense for the human subject to look at it. And then from there, we track the gaze map pattern and the EEG. So in that sense, eventually, given the preferred aesthetic score, we could generate a facade that hopefully align with that aesthetic score. So some close-up view. of the models. This I think I can skip. So this project actually is trying to look at the endless theater, the total theater, what the graph is, right? And try to use the theater as the ultimate multi-model prototype for understanding different AI models. So meaning, so just very quickly, you can check out papers. So you have, it's based on Hamlet, right? To be or not to be, and then you have the script, and then from the script, we have this interpretation into a spatial with spatial attributes, and then from the spatial attributes, we generate the images upon the pose of the actor, so that we capture his feature, his expression and his positioning. And then we generate the frames, and then we do the interpolation with image to video, and then to generate a new performance. And then after that, this is the actual performance. I'm not plugged into the audio, but essentially, it's Andrew Scott performing for BBC Two, I think. And then we grab that video and begin to regenerate. So this project, it has nothing to do with EEG or the brain eye tracking, but the idea is that after that we test it with a person looking at it differently, and he actually performed completely differently given what he's seeing in the video with the exact same script. He performed it. You probably can't hear it, but anyway, I think you can hear it. And versus this one, so even if you look at the ways in which he acts, is way more hot, relaxed, which is the sort of impact on him. Yeah, I'll just end here because I think I've exceeded by 10 minutes. Thanks.
Oops. Let me switch the camera for a second. Okay. Immanuel, thanks so much for the presentation. That's obviously a lot of work you've done in the past years. I would like to ask you something, and then perhaps we can open up to the students as well if they have some questions for you. So if you were to give a sort of critical overview of your work within the lens of how you deal with projections in a very abstract way. So by projection, I mean you deal with a certain modality of data, and you're trying to produce something by projecting it to other dimensions, whether or not they are in space, right? And I was wondering how, so throughout all of these works, if you could tell a bit more retrospectively on how you understand this transformation. So from one mode of abstraction, which could be a data set or the way you construct a data set, to another one, which is projecting it into 3D, 4D, or even simpler 2D as an image, to try to express something that has an architectural value.
Mm-hmm.
Does it make sense?
I try to answer if I hopefully understood you correctly. But there is, if you look at the in a quite formal sense, there is this search of the, some in the early days of AR artwork, it's all about the uncanny, right? There is this search of the glitch, the unexpected, right? But in this case, there is this, at least the way in which I conceive it is that I feel that these models have some kind of via their artifacts, some kind of aesthetic inclination Obviously, with new models, some of these artifacts will begin to disappear. So it's an ever-evolving kind of search of the trace, right? And these traces may exist in different modality. So that's something that you may see, you may not see, but it's something that I'm actually very keen and trying to conceptualize it. So if you recall back in, I think, 2012, there was this movement called New Aesthetics, right? James Bridle, where it was really about uncovering from the glitch. Let's say the famous image was the plane, right, with the RGB being split from the remote sensing satellite imagery, and it is a way to articulate the underlying technology, and it is that the presence of its constituent ingredients, right? So same thing, right? The very fact that we see that the bench has this two-sided geometry is because of the nature of, or rather the abilities of these non-3D aware models that we are using them to generate 3D. So it sort of escape our typical conception, which I find it creative and interesting, and also more involved as a practitioner, rather than just, you type some prompt and you generate something. It feels like there's a greater degree of authorship. Actually, for that project, it's also about, so on the one hand, it's sort of, the idea is to blend concepts of boats, and which we call it sampan in Singapore, these small boats, historical stuff, and also the Peranakan, which is a Chinese Malay mix of aesthetic. And so, by looking at the furniture, so conceptually is trained on these design characteristics, but materially they're actually upcycled 100% from abandoned, antique chairs, abandoned boats. So it's trying to fuse that in materially and conceptually. And talking about the multi-modality thing, I think it just makes sense, right? Because as we had a discussion previously, our frustration with a linguistic heavy approach currently, and just doesn't make sense, as I tried to demonstrate in the spatial reasoning part, where certain things it's just very, very difficult to articulate as language, as text. And it feels as if we're missing a lot. And of course, that's why the multimodality, and obviously multimodality would mean any modality. Could it be EEG as well? Could be images, whatever, doesn't matter. But just like how we describe a building, right? Could be with text, could be with image, could be with 3D models. There are so many ways to approach or encounter architecture. And it only seems to make sense to leverage this approach. Yeah.
Mm.
Yeah, makes sense.
No, absolutely. And it was for me a way to slowly get back to actually our discussion on trying to get rid of overarching syntactical ideologies in this kind of models. And what I wanted to ask you again is also, I know that after discussing with you, we have very similar interest in tapping into physiological data as a way to try to overpass semantically constructed explanations, as verbally explaining, constructing in a well-formulated sentence with very well-established language, a way an architectural artifact can have a value. And somehow, what I find interesting in physiological data is that we can find certain gateways, certain channels of communication, where we can access very, very early the way we as individuals, as psychophysiological entities, are also producing this value. And I remember a very early talk of Demis Hassabis about artificial general intelligence, saying something like, okay, we can get as far as interpolating 2 points in a data space where whatever is in between, we can recreate something which is at a certain distance between those 2 points, just like early GAN models. Every kind of representation learning model does this kind of very, very explicit way to produce something between 2 data points. And he was saying what we should be looking for in generalizing artificial intelligence is to extrapolate, to go beyond the boundaries of the data that we know. And somehow I still believe that even though in a lot of ways, when we are tapping into physiological data, we are anyway also at the very boundary between something that is linked to language. So for example, attention, visual attention is very linked to language because this is the weight we are putting to things we are looking at is also directed with long-term memory, and therefore there's a lot of anchoring from language, which we can call intentions, for example, from a phenomenological point of view. But still, because we are at this boundary, we are at this full truth, this point of articulation where we are producing meaning. I think it's extremely interesting because we can couple the very powerful generative aspects of very productive interpolations of data while trying to either breaking down and make the latent space more sparse in terms of regions of interest, which don't need any further explanation that we like it or not, or trying to, as you mentioned, to drift the understanding of a latent space, of a solution space beyond its boundaries. And I think this is something we can only do if we go as early as possible in the way we can produce those values, in the way in our physiology we can observe those events. So I really strongly believe in that. And I also think that it is really, we will never really manage to get rid of language. But what is interesting is if we can always push it, if we can always try to go to the most primitive aspect of it as early as possible in time, for example, we could get something novel. We could maybe talk about novelty in the way we create values. So this was this was my additional comment to our last discussion, and I was wondering if you wanted to also add on top of this, or if you had a different opinion about that.
Yeah, I mean just like Margaret Bolton talk about this combination, transformation, creativity, right? I mean, if you can also think it in terms of extrapolation is essentially to change the latent space itself, right? So for instance, if the model get updated with new concept drift, then the latent space changed. But for me, really to do transformational creativity is to change the latent space, because it's not possible to extrapolate in a sense because you are within that space and it's kind of decided, right? And that space is also modality specific, right? So when you talk about projection, actually is you project, into the embeddings, right? You combine the embeddings of images, of text, but in the from EEG, the brain physiological perspective, is that yet articulated concept, So it's pre-concept. You know what I'm saying? It's pre-concept because we have not given the word to the concept. So that means that latent space is also primitive and therefore has a greater variability before it becomes a real latent space. So to me, it's extremely powerful because that might be one of the few ways to actually do transformational creativity, where the concept space, the mind space, like when we do alignment, right? That's why, you know, like philosopher or anthropologist, those guys, those language people, they're very good with this talking to ChatGPT, right? Because they can align the mind space of their mind space with the mind space of ChatGPT, and therefore the pre-concept latent space is that variable space that we can play a lot. And if you begin to, I'm just even talking about this yet no modality yet, right? Because when talk about that concept yet to become concept space, is it could be from the brain waves, it could be from the, I don't know, other parts of the body, right? Which is inherently multimodal. That would be very interesting. And also to begin to question this is from a sort of a pedagogical educational perspective also. In the past, architects are known, we're great, you know, in visualizing, right? In drawing up, you know, to do the translation of the concept to the design, the visual. But we're not actually extremely great at this sort of linguistic communication with models, which obviously could be trained, but again, we are missing out our own agency as designers. So that's why I'm also interested to begin to even extrapolate our skills. That do we need other skills beyond, in the past, beyond just rendering cool stuff and then, you know, set it off as a project, right? But now this is nothing. So what else can we offer?
Good question. Thanks a lot. I will turn the camera on. And guys, do you have any questions for Immanuel? It can be anything, really, from something you did not understand from the presentation to something else you think is related to. Anything that piques your curiosity? Yeah, go ahead.
Just technically, I want to know what kind of tools or techniques, what kind of tools to be used for your research, with training these models and also with this to collect this EEG data and this like point cloud manipulation. What kind of tools to use for the research?
Did you hear that?
Okay, yeah, I can't hear clearly because it's a bit distant from the mic. So can you, if you can, repeat.
Yeah, I will repeat. And
for him, yes.
The question was because we are dealing with a lot of this is an introductory course, and we're also dealing with a lot of bachelor students as well. And they were wondering, while looking at all your work, which kind of CAD tools you're actually using in your research and in your teaching.
Right, a mix. But when we mainly, you know, on with PyTorch. I mean, if you talk about the library, I mean, of course we always search things on Hugging Face, right? Which is very convenient. But sometimes in early, quick testing of some ideas, sometimes we just directly use, you know, Runway or the standard stuff, right? Stable diffusion. But when we want to, like for instance, when we did the bench, there isn't this existing. You may find many codes, but often when you want to do something specific, part of it is this in this other code base, part of it is in this other code base, and that's when we have to do it because we have no other choices, right? So, and often PyTorch is the main programming language that we use for all the models. Early on, we mainly using TensorFlow, Keras, but these days just PyTorch. But we combine other ones. We also use, the standard Kling AI, Luma AI, just to test quickly some initial ideas, and before we see if there is a need. Of course, we also do Comfy UI, where you could just quite quickly, in a grasshopper sense, quite quickly combine existing models to test out stuff. Yeah, quite a mix. Depends on the task. For the theater work, we use a lot. With Runway. Yeah. I think Christoph has a question.
Yeah, Christoph, go ahead.
Thank you. Yeah, and thank you, Immanuel, for this presentation, right? I think we've been in touch for a while, but we never met. Obviously,
Yeah.
next time I come to Singapore, which probably will be at the end of next month, maybe we should really have a conversation, because your portfolio is quite striking, I must say. There's tons of stuff we could discuss, also related to Pierre's comments and quite programmatic statements that he just made, right? But maybe let me just come back to one thing that's close to my home discipline as a behavior scientist, namely this incorporation of feedback data from humans that are exposed to the digital environment, right? Be it with the eye tracking, be it with the neural signatures, and I think this frontal asymmetry is a really nice measure. In psychology, these techniques are also used, and some of the work in our own team clearly also does that, right? At the same time, the gold standard for many of these assessments of what is the person's opinion or perception of something ultimately goes via language again. Not necessarily in the response mode of language, but the way that the participants gain an understanding of the tasks, and maybe they give their response either verbally, or they have to make a yes/no decision, which at some level is also linguistic, because yes and no, or 0 and 1, are the smallest units of any linguistic structure, right? Or you can, by combination from zeros and ones, generate anything, and clearly that is also the logic of anything that happens in an artificial design space, right? What strikes me as really fascinating in the approaches that both you and Pierre push is why wanting to avoid the linguistic, right? And I can see quite a few good reasons. One is speed, right? So if you're really interested in very early response, you can of course also have a much more dynamic way of generating the stimuli or the materials, and measure people's response to it. So if this is a co-discovery in a vast design space between a human and a technical support system, then bypassing language might be very useful for speed reasons. Or it might be very useful to overcome preconceptions that come in via meaning, via language, etc. And I'm very much on board with that. But in the end of the day, it goes back. It then leads us to very fundamental question about aesthetics and architecture again, that become very relevant in any kind of simulation environment. We also have it when we have generative algorithms, when we have agent-based systems that generate architecture, whatever. In the end of the day, you always want to have some kind of reward function or criterion against which to optimize, right? And then we revisit again the question of what is the role of the human in assessing the quality of architecture? Ranging from is the assessment of quality of architecture an expert task or an end user or layperson task, right? That's the first layer. And the second layer, is it their immediate response that you should cater to as a designer, or is it their more reflected response, right? So is it the criterion to which I optimized how people perceive or evaluate a complex architectural artifact in runtime within a few milliseconds or maybe a second at best? Or are we more interested in longer term elements such as some deliberation about the quality or even long-term exposure, right? Imagine having to live in some of the buildings that or architectures that are being designed. And this is not at all as a criticism to the approach. I think it's super fascinating that you have these approaches, but I do think it touches then ultimately really on these matters of what is architecture for and how do we evaluate its quality, if at all.
I mean, I don't know if you have read the more recent book by Hedderwick, right? Hedderwick, Humanized, right? That's the name of the book.
Yes, I
Humanized. Right. So it's quite interesting because it's almost anti-expert, anti-architecture elitist, anti-Corbusier, at least for the first half of the book, before he talks about Ronchamp. And he had some, in an interesting way, some way to sort of measure, right? He talked about the facade and it captures you for that many seconds or minutes. It is something that is good. So there are some kind of a criteria, which is, so these are like immediate without articulation, because if someone just passes by the building, he can say something, but we don't need him to say anything, actually. He just, and the idea, how it sustains your attention as you explore the buildings, right? Which again might be a way to measure. So again, the order and complexity should be order enough and complex enough to sustain your attention. And then that's just a facade for him, right? But actually, there's this other book, non-referential architecture, where it's about going to the space and able, let's say, if you enter the space and you see a flight of staircase, and that was one of the examples. And the idea is that if you're attracted to move on to explore the turns after going up the stairs, that means it's quite successful because it trigger interest, not just attention. It moves your body. And for those who are living in there, of course, after a while, that novelty would be gone. Then I completely agree with you. It would be interesting to do a more sustained research of the aesthetic experience as residents in a kind of a longer duration of time. Yeah, so I don't know. So maybe it's about optimizing the the attention span of, not just looking but interacting, right? One is bodily on the inside, on the outside, because you can't go in because of the private property. You have no choice but just look at it. But his argument has some problems too. It doesn't quite work for like skyscrapers, right? Because there's a different way of looking at.
But thank you, Immanuel, for making the link with these two authors, right? I mean, Thomas Heatherwick is a funny guy, and actually, my team was also involved in some workshops with them towards that book, and so that's fun. But this link to non-referential architecture, I think that resonates a lot with Pierre. Allow me to make that link with a couple of inputs we've had previously in this seminar, right? So when Chris Salter 2 weeks ago spoke about Gibsonian perception and also about affordances, right? This non-referential architecture is the same logic, but in different terminology. And I think looking at these different timescales, super interesting. Thank you.
Yeah. And it's obviously a very, very touchy point. Because why does it really matter to talk about this now, after we had, so many discourses about trying to establish adequate vocabulary to try to be adequate in each own's time. And I think there are two. I don't really share personally this idea of non-referential architecture. I don't think there is such thing. From a cognitive perspective, it doesn't make much sense, but okay. But I personally believe that the reason why we are so sensitive about the question of language now is because, Well, first of all, it's because of a trauma. So in the history of architecture, post-war architecture has been dealing with a lot of trying to establish new stable structures to express the new conditions of life. So for architecture to feel adequate, to find its own vocabulary, it was lacking a proper structure, and language was too evasive, it was lacking the strength, the abstraction we thought it would to be able to do that. So left alone without any proper structure upon which basing a new vocabulary, we thought maybe new ways. Some are a bit more decadent and trying to get rid of any idea of structure. And one of the interesting gateways with AI, and throughout also the massive collection of data through social computing and so on, was to say, well, we can, first of all, we can interpolate whatever we have done so far to try to understand the limits of our own vocabulary, of our own expressivity. But where does it lead us, if not to these boundaries? So if we are not to look at the horizon of how, as designer, we can keep supporting the expressivity of life, try to build, to make buildings, to design things that express it in its most diverse and evolving way, how can we do that? So, and still language is not adequate yet. It's our struggle. We cannot deal without language. We cannot communicate without it. But in the dimensions, and this is now maybe something a bit more personal, but in the dimensions of language, there is the idea of thought, which can be seen as preceding the formation of language, still interacting with it in its own temporality. And while we are on the technical pathway to integrate a lot of semantic descriptions, so anything as some kind of object which can be described almost exhaustively can be generated artificially, in a sense. Yet, what remains is probably how we value this object. How does it make sense to an individual, which is completely different across a lifetime for one individual and completely, arguably different for a collective as well, depending on so many environmental factors. And I think this is a richness we are lacking to express as designers, as architects, because we are lacking the proper modes of expression for that. And I think really the kind of the landscape to find this expressivity, this new way to express this life support now is to deal with both artificial and, between quotes, natural intelligence. That is something we just cannot model. That is something we have to deal with, and it is an inherent part of it. So there is speed, of course, which is trying to keep up with the pace of generativity, but I think, qualitatively speaking, there is this missing component in generative design that is about aesthetics. And that is, I would say, almost impossible to model or to digitize. The only thing we can do is to try to develop communication channels, which are hybrid.
Sounds agreeable.
That would be my answer as a designer and an architect, I would say. In order to be able to articulate things, to talk about architectonics in this world, in this time, we need to deal with both the capacity of generate a lot of things from what we know, and to interact with it with what we cannot describe. and that is with our own mind. And I don't know if Immanuel is on board with that. He might disagree. We haven't talked about this.
I mean, to me, this is the obvious deficiency. I mean, it's also hindering the AI architecture research. I mean, there's so many, right? Text to image, image to image, like there's so many, right? But it looks like convergence than actually divergence because they all look quite similar. And I mean, so then they move on to the trace of workflows, right? How you can recombine to create, but then they hasn't qualitatively changed much of architecture, not just in terms of aesthetics, but in terms of conception, right? And yeah, so in a way, I agree that we should take on that implicit part of us that is beyond language, but also, I also, in a way, agree with Christoph that since we have that, we should just also use it. There's no real reason to remove this additional modality that is not exactly democratic, but at least generic enough. Of course, we're not talking about neurodiversity kind of thing as well, but essentially, it's a shared language, and which is also the problem now, because then we sort of lose our own architectural language in that sense. Yeah. So I kind of I think we should make full use of what we have and try to get hold of what we yet to have, yes, which is the whole kind of brainwave stuff.